All right, welcome back. So sometimes we can have experiments where one outcome can differ from another depending on the order of the different parts of the outcome. So what does this mean? Let's see an example. So we saw on the experiment where we have the coin flip and the die roll that initially we can get either heads or tails, and then we can have a 1, 2, 3, 4, 5, or 6 on the die. Similarly, if we get a tails, we have the same possibilities on the die, 1, 2, 3, 4, 5, or 6. So we saw that our sample space has 12 elements. We're using the multiplication principle, so we have 2 times 6 equals 12. So each individual outcome, we'll take for example h and 2 is equivalent to 2 and h. So if we get a 2 on the die and we get a h on the coin, it's the same as getting a h on the coin and a 2 on the dice. But sometimes the order actually matters, like say if we're using a password. So we'll have a look at that next. So for our password, we'll keep it simple. We'll say to make a 2-character password with a letter between A to G and a number between 0 and 9. So a possible password that we could choose would be 2D. And that is not going to be equal to D2. And similarly, if we were to choose, say, 0A, that's not equal to A0. So how do we actually count the outcomes for the passwords? I'm sure it's clear then that there's 2 different sections where we're going to have one password where we choose a letter and then a number, and another type of password where we have a number and then a letter. So say a letter and a number, we're going to have A1 or 1A, and these are distinct, so they're not equal to each other. So for our letter, we're going to have a choice of 7, A to G, so A, B, C, D, E, F, G, 7 times 10 numbers, 0 to 9, we're using the multiplication principle. So we're going to have 70 possible outcomes. And similarly, if we have a number and then a letter, then we're going to have 10 choices for the number times 7 for the letter equals 70 as well. So because these 2 passwords are distinct, we need to count them twice. So 2 times 70 equals 140 possible passwords. Okay, so hopefully you have a good grounding in counting and ready to move on to the next topic in probability. Thank you.